So today we'll be going over differential equations. So what exactly are differential equations? I'm sure we're all familiar with seeing equations such as y is equal to x squared plus 3x plus 2 and so forth. But for instance, differential equations on the other hand, they actually contain derivatives in them. Let's say for example y double prime plus 3y prime take away y is equal to 0. Without knowing what the function y is, you actually this is your starting point of differential equation, and utilizing different methods, you're actually able to solve what that y function is, as the first example was given. Now, a practical application that's obvious going back to your physics course is one of your kinematic equations, which we all know and love, right? Final velocity is equal to your initial velocity plus your acceleration times time. Now, how exactly did they derive this equation? Well, it was utilizing differential equations with your starting point being something similar of this equation with derivatives, and then utilizing multiple different methods to actually come up with an equation at the end of the day, such as this. And this was how kinematic equations were derived, which we'll be learning soon enough. Now, there are different classifications of differential equations. You have what's called ordinary differential equations, or ODEs, which essentially is an equation that has only one independent variable. So let's say, for example, dy with respect to x plus 5y is equal to e to the x. Another example would be, let's say you can have multiple variables, but as long as it's with respect to a one independent variable, let's say dx dt plus dy dt is equal to 2x plus y. Another classification would be partial differential equations, which is PDE, which would be, for example, dx with respect to t plus dy with respect to another variable. Let's just call it v for whatever reason, and so on. That would be example of partial differential equations, but we'll mainly be focusing on the ordinary differential equations, as well as the order of differential equations. So the definition of what the order of a differential equation is the highest order derivative appearing in the equation itself. For example, you have, let's say, dy dx is equal to 3xy squared plus sine x. Now, in this case, this would be a first order differential equation, ordinary differential equation, because you have your derivative being only your first derivative here. Let's say, for instance, if it's the second derivative of y with respect to x, and you have the same, this would be your second order, and so forth. Another thing to keep in mind is the different notation used to actually describe a derivative. You usually are familiar with dy dt, or the second derivative of y written in this notation, or you could actually see it as y prime, y double prime, triple prime, and so forth. There's also the what's called the dot notation, which is like x dot, y dot, which essentially just means whenever you see a dot of it is the rate of change of y with respect to time itself. And so just one thing to keep in mind as well. Now, just like regular equations, you have both linear and nonlinear equations. The same goes for differential equations. You have both linear and nonlinear differential equations. Like, for example, you have, let's say, y double prime take away 2y prime plus y is equal to 0. Now, this would be classified as a linear equation due to there being constant coefficients, as well as the derivatives of y and y itself, they're not being squared, or there's no power exponent besides 1. Now, let's say you have x cubed the times the second derivative dy with respect to x plus x squared. the first derivative of y with respect to x, and so on, this will still be classified as a linear equation due to the coefficients. They depend on the independent variable itself and not the dependent variable. So let's say if it was y cubed, the second derivative of y with respect to x, now this is when it would be classified as a nonlinear equation. But otherwise, this one is linear, this one is linear, and so forth. Let's go with a few more examples about linear and nonlinear. So let's say another example here. Second derivative y with respect to x plus sine y is equal to 0. Now since sine y, this would be nonlinear. So this differential equation will be classified as nonlinear. Another example would be the fourth derivative of y with respect to x plus y squared is equal to 0. Now in this case, this would also be a nonlinear equation due to the power exponent on the dependent variable being anything other than 1, right? It's squared, cubed, and so forth.